Our next objective is to be able to determine the domain and range of a function, specifically from a graph. Later in this course, we will look at determining the domain of a function from just looking at the equation, but for now, we're just going to be looking at finding the domain and the range from a graph. So we've already defined domain and range. If we have a function, the domain is the set of x values in the function, and the range is the set of y values in the function. So just as a quick example, if I come back up to example 3, we saw that this relation was a function. Its domain would be the set of x values, which were -2, 6, and pi, and its range would be the set of y values, which also happened to be -2, 6, and pi. So in that case, the domain and the range were the same. But over here, perhaps this is a better example to look at. Example 2, the domain would have been the set of x values, which were 1, 2, and 3. And the range would have been the set of y values, which were 3 and 5. All the numbers in the y column, all of the y coordinates. So what we're going to do now is we're going to determine domain and range, but we're going to do it from looking at a graph. So here we have a graph. Later on in this course, we'll study these types of functions. This is a quadratic function. Its graph is a parabola, but what we're focusing on now is its domain and range. Before we find the domain, I want to emphasize that the graph has arrows on these endpoints here, meaning that it does not stop. So this graph would actually continue on forever and ever. It goes up and up and up, and it continues to get wider as it goes higher. So for the domain, we're looking for the set of x values. Well, every single x value is in the domain of this function. The domain of this function is all real numbers. And we know that because, like I said, this graph gets wider and wider. So every value of x, let's say I choose the value of x4, is in the domain of this function, because I could find a point on this graph. I don't know what the y value is, it's not important right now, but I could find a point on the graph that corresponds to the x value of 4. Even if I chose an x value of -20 all the way out here, as this parabola continues to go up, 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 eventually there will be a y coordinate that corresponds to -20. So the domain of that function is all real numbers. Another way you can imagine finding the domain of a function is imagine that you are a tiny little ant walking along the x-axis, and you want to be on the x-axis, that's an ant. You want to be on the x-axis because domain deals with x values, right? When we do the range, we'll get on the y-axis. But imagine you're a tiny ant walking along the x-axis from left to right, and as you walk along the x-axis, you're looking up and you're looking down. And you're asking yourself, do I see the function? Well, if you're walking along the x-axis all the way starting out from -infinity and you look down, you won't see the function. But if you look up, you would see the function because, again, remember, this continues to extend out. So you see the function all the way from -infinity as you continue walking. You will always be seeing the function as you look up. As this ant continues along the x-axis towards the direction of positive x values all the way off to +infinity, that ant will always be able to look up and see the function. Now let's think about the range. Range deals with the y values of the function. So we need the smallest y value to the largest. We're writing intervals, and we're always writing them from least to greatest. The smallest y value this function achieves is 2, right? There's no y values below 2. And because 2 is included in the range, I'm going to put a bracket on it. So it's the first number I wrote because it's the smallest y value. I'll put a bracket on it because it is actually included in the range. For instance, we can see this point 2, 2 here, and it is this 2 that we're talking about, the y value. And then the range goes on forever up until infinity because we have all of the y values that are greater than 2, and infinity always gets a parenthesis. We can play the same game with the ant to determine the range. If I'm an ant walking along the y-axis and I'm looking now to my right and to my left, I'm asking, do I see the function? Well, we don't see the function until we get up to 2. And then as we continue to travel up the y-axis, looking to the right and the left, we would continue to see the function all the way up until positive infinity, which is why the range is from 2 to infinity. Moving on to example 18, let's start with the domain. If we are moving along the x-axis from the left to the right, and you have to go from left to right for domain and from bottom to top to range, because it needs to be written in order. We would see the function all the way out from negative infinity because we have this piece here with this arrow that continues to extend out to the left. So the domain starts at negative infinity. We continue to see the function as we're walking along the x-axis. You may wonder, is 0 in the domain? Because as we get to the y-axis right here when x is equal to 0, if we look up, we would not see the function because that point is open. But if we look down, we would see the function because this point is closed. Open means excluded, closed means included. So 0 is in the domain. So we don't need to break the domain up. We just continue moving, and we would continue seeing the function as we look down with this piece that dips under the x-axis, and then when we get past whatever this x value is, we would continue to see the function as we look up because that piece continues to go up and stretch out to the right. So the domain is all real numbers, negative infinity to positive infinity. Now let's determine what the range is. To determine the range, we have to start at the bottom of the y-axis and work our way up. As we start from the bottom, from negative infinity, if we look to the right and the left, we would not see the function until we get to negative 10 because we would see that dip right there. So the smallest y value in the function is negative 10. And then we would continue to see the function as we move up. Even as we get to negative 1, we continue to see the function because we can see that piece right there. When we get past negative 1, like say we're right here, we would continue to see the function because we have that piece right there. Same as we go up between 1 and 2, all that's in the function. You may wonder, is 2 in the range? Because again, we're coming up to this open point, but 2 is in the range because if we're on the y-axis, if the ant is on the y-axis at 2 and they look right, they will pick up this piece of the function right there. And they will continue to see the function as they go on to positive infinity because the graph continues to extend upwards from either direction. So not both, but the domain is all real numbers and the range is from negative 10 to infinity. In example 19, let's start with the domain. As we begin on the x-axis, starting from the left at negative infinity, this piece here continues to extend out, so the domain does begin at negative infinity. As we move along the x-axis, we continue to see the function. When we get to 1, you may stop and wonder, is 1 in the domain because this point is open? 1 is in the domain because that point is closed. So we continue moving along the x-axis past 1 until we get to 4. We do see the function at 4 because we have this point here if we look up from the x-axis, but we do not see any of the function once we get past 4. So the domain stops at 4, and I'm using a closed circle there, or a bracket there because this is a closed point. If that point were open, then I would have put a parenthesis on 4. If you're wondering why the domain stops at 4, say we're at 4.5. If we look up, we will not see the function. And if we look down, clearly we will not see the function either. So that is our domain from negative infinity to 4. Notice that I did not break it up at 1 because 1 is included in the domain. I can see it right there. For the range, as we start at the bottom of the y-axis and work our way up, from negative infinity, moving up, we don't see the function until we get to the y value of 1, right? Because down here, as we look right and left, there's nothing to see. When we get to the y value of 1, we do see the function, so 1 is in the range. I'm just going to put a 1 for now. But then once we get past 1, say we're at 1.2 right there, if we look right and we look left, we do not see any of the function between 1 and 2, right? So 1 is in the range, but it's a single number in the range. It's not an interval for that piece. It's just 1, this horizontal line that's hitting y is equal to 1. Once we get up to 2, we again see the function from that second piece with the closed point. So I'm going to union this to glue those two pieces together. The range picks up again at 2, bracket because this point is closed, and then the range goes all the way up until 8. And it stops there because that piece does not have an arrow on it. It just ends there. And again, I put a bracket on 8 because this point is closed. So notice this closed point, which is the point 4, 8, where the graph stops. We see the 4, which is the x value showing up in the domain. And we see the 8, which is the y value showing up in the range. Okay, on to our last example where we find domain and range. Please ignore this dot right here. Just act like that's not there. I'm not sure why that is there. But as we begin on the function, on the negative x-axis, moving to the right, we would see the function out from negative infinity because this piece here extends down forever. So even from negative infinity, as we look down, we would be seeing the function. And we would continue to see the function forever because we have an arrow here showing us that this piece continues to drop down. So the domain is all real numbers. Now let's deal with the range. Starting at the bottom of the y-axis and working our way up. If we're on the y-axis from negative infinity and we look left, we would see the function. So the range does start at negative infinity. As we continue to move up the y-axis, we continue to see the function as we look to the right or the left up until we get to 4, because the function does not go higher than this point right here. So the largest y value in that function is 4, and it is included because it's not an open circle there. It's just the function continuing. So I will put a bracket on 4. When I teach finding domain and range from a function graphically, sometimes there's a lot of questions about it. So if you have any questions about this, please make sure to either post your question, let me know, or ask me about it when you see me in class, and we can go over some examples together in class as well.